Hello, everyone. Great to be here today at the AsyncAPI Conf. My name is Luke. I work at the Lego Group as a lead engineer, and I'm going to talk to you today about cross-domain events with AsyncAPI and AWS. So let's dive straight in. So let's talk a little bit about event-driven architectures. And I've broken this down into kind of two phases. What we tend to see with adoption of EDAs. First phase is very much about events that happen within your domain, within your product, within your application. We make our inter-service communication event-driven. A service fires an event, another service consumes that event. And that's all good. That gets us used to this kind of event-driven way of working. And then what we tend to see as our applications, as our EDAs mature and scale, is we start to see cross-domain events. So domain A sends events, and domain B consumes those events. And here, what we start to see is the real power of EDAs begin to be unlocked. And that's really what I want to talk to you today about, is those cross-domain events and how we can manage those at scale. So a little bit of context about the experience I'm basing this talk on. I work on the payments platform at the Lego Group. And we were tasked with this task to produce rich payment events in real time to consumers via a transport that is convenient to them. So we're going to look at each of those little pieces. We'll break that down and see kind of the sort of solution that we put in place. A little bit more context. So these are the kind of domains that we're working with here. We've got the payments domain in the middle of the screen there. And so that's kind of going to be the central point of this talk. That's going to be the producer of our cross-domain events. And we've got a couple of other domains here in the flow of a payment and an order on lego.com. The baskets domain, they'd be responsible for the front end on the checkout process on lego.com, and the order submission over to the orders domain. And what we're really interested in here, the particular event that we're going to focus on, is the idea of a payment being authorized. So once you've made a request to pay for some Lego with your preferred payment method, that payment request will go off to, if it's a credit card payment, to say the issuer of the card and the bank. And if everything is okay with that payment, we class that payment as being authorized. And at that point, the payments platform would receive an authorized event from a third party. And we, as a payments platform, need to tell our consumers about that successful payment authorization. And the baskets domain is really the domain that's interested. Once they have that successful payment authorization, then the order submission can take place and the Lego will be on its way to you. So before we had this event-driven Nirvana, there was an existing solution. That was very much a pool-based solution where the baskets domain, after submitting a payments request, would continually poll the payments platform to ask, has that payment been authorized? And they would keep asking that until the payments platform had received the upstream event that the payment had been authorized, and we would send that status back in response to the request from the baskets domain. And then we can see there the order submission would continue after that. That pool-based mechanism puts a lot of emphasis on the baskets domain. There's inefficiencies there There's time spent for a shopper on the checkouts page, waiting for that response to come back. A lot of things to improve, and that's where push-based event-driven mechanism works a lot better. So the baskets domain would submit their payment request as usual, and then just wait for a response for an event, for a notification from the payments domain that payment had been authorized, and then the flow continues. So this is the event-driven cross-domain solution we've ended up with. Now there's a few desirable properties that we're going to be looking for as we build out a cross-domain event-driven architecture. Of course, events need to be consumable, but the process with which a consumer can set up consumption of events needs to be simple. And what we talked about there when we looked at the original task was that familiar delivery, the transport that was convenient for our consumers. There's lots of different ways to deliver events. There's lots of queuing systems, message delivery systems, event buses, and it's about, so if you're developing your own solution for cross-domain events, the best tech for you and your consumers is going to be the one that should win out. What we didn't want to do here in our case was introduce an event delivery system that was unfamiliar to our consumers, and introduce additional tech burden upon them. Events need to be discoverable and well documented. This is something we'll look closely at, and where AsyncAPI really helps us out. And standards is so important when we're dealing with cross-domain events. It's important when we're dealing with inter-domain events, but even more so in terms of cross-domain events, because having a standard way to design, define, deliver events makes them interoperable, makes them portable across systems. It gives us a shared language between producer and consumer, and it makes them predictable. And that's also where versioning kind of complements that standardization. It's all about making events predictable, event payloads predictable, and maintaining backwards compatibility whenever possible, not breaking event handling when we change event payloads and message structures. Security is super important, especially in the domain that we were looking at, and kind of dealing with payments data. But whenever we're delivering messages cross domain, in particular, security is really important. We need to protect any data that's in those events. Treat any data as sensitive in this respect. And because the event is likely to be received via a public endpoint, messages need to be verifiable. You can imagine that someone would be able, if they knew the domain, if they knew the API endpoint, they could post a message. But we want to provide a mechanism for our consumers to verify that the message is from a trusted source. And we'll look at how we achieve that. Scalable, we're talking about pretty high volume here in terms of payments events through Lego.com, through the use case that we're looking at. That's super important. Any event-driven system is likely to need to deal with high volume. That's the nature of events. And resilient. The payment authorization event that we're looking at here is very critical. That is the link between the payment request and the order for your Lego going out. So any missed events can mean disruption to a shopper's order. So we need to build an event delivery system that's tolerant of faults, of network errors, We need to be able to replay missed events. We need to be highly available at all times, really. So what we're going to do, we'll focus on a few of those points. The first one we're going to look at is that standardization, because it really is so important when we're dealing with events. There's tons of ways in which we can express event payloads. So adding standard specifications around that is super important. And this, of course, brings me on to AsyncAPI, and the reason we're here at this great conference. Now, the AsyncAPI spec, most of us are going to be familiar with that, but this has really become the industry standard for defining asynchronous APIs. Just as OpenAPI has served as well in terms of synchronous APIs, request response APIs, AsyncAPI is really shining when it comes to asynchronous APIs. And there's this growing ecosystem of tools for building these event-driven APIs and for operating them. And that's what's great about AsyncAPI. There's this whole community around it. And I feel like we're really just at the beginning of what's possible here. And it's great to be a part of that and being a user and a contributor. So that's really great. And if you haven't tried out AsyncAPI, definitely go ahead and do that after the conference. Here we have a small example of what an AsyncAPI schema would end up looking like, and this was a slimmed down version of what we ended up with this payment authorized event. Now, when we talked about the event delivery system and the need for a kind of familiar transport, Amazon Event Bridge became the obvious choice for us. So if you're not familiar with Event Bridge, it's a serverless event bus, and it has this really powerful mechanism for filtering, which is based on rules and pattern matching, and it's fast becoming the go-to application integration tool within AWS, and it's kind of taken some of the use cases away from things like SQS, SNS, Kinesis, which you may have come across or used in the past. Now, EventBridge was in use internally within the payments domain, but also within our consuming domains. So it definitely became the obvious choice. There was no new tech to introduce. And internally within the payments domain, we already had events flowing through our private event buses that we could subscribe to and transform and send on downstream. And another key benefit of EventBridge is that it allowed us to target AWS workloads. So we could go from an event bus in our account, in our AWS account, into an event bus in another AWS account, i.e. the baskets domain. We could do that event bus to event bus. But it also allowed us to target consumers who are perhaps not using AWS or not using EventBridge, and we could do that via a regular HTTP request using a feature of EventBridge called API destinations. And here we see an example of an infrastructure as code definition for provisioning a rule on an event bus in EventBridge. So we can see here, again, it's a very simplified example, but we've got the payments public event bus defined there. We have the target of the buckets public event bus, baskets, public event bus, and the event pattern. So we're saying here, send all events from payments through to the baskets domain that match this event type, payment authorized, ecom or e-commerce. Those are the payments that the baskets domain are interested in particular. So you can see that kind of powerful filtering system coming into play there. And we'll dive into the detail of what an event could look like as well. And that's really where CloudEvents comes in. So CloudEvents similar to Async API is this kind of industry standard, industry leading specification. But whereas Async API is for the kind of wrapper around your API, the API itself. CloudEvents deals with the payload of an event, the event data itself, and it gives us a common way to define all the fields in that payload. An event payload is often this kind of unstructured JSON object, or and you know, the keys used were completely up to the producer. The consumer would kind of have no idea what format the event was going to kind of turn up in without reading documentation. And what we see here is if that's the case, if there's no standard way of defining the keys and the values in an event payload, the complexity for a consumer to handle those events is huge. Each event needs to be handled in a different way. We can't standardize any of the handling logic. Whereas when we introduce CloudEvents, that complexity and that amount of handling logic is drastically reduced. So here we can see you know, a basic example of what a CloudEvents payload would look like. You've kind of, most of these are, you know, typical standard keys in the payload, and we have some non-standard, some custom ones as well, and they just sit alongside the standard keys in the root. So item potency key is one that we've introduced to this event, and we'll get on to kind of how we generate some of these fields in our event payloads. We'll get onto that a little bit later on. But you can see here the type of the event coming through here, and the source. So a lot of these things will look familiar. So the first thing we had to do when we decided on these various technologies and specifications, we had to kind of trace our way across the three specs and find the commonality, map between the fields, the field names that were defined in each spec, and that would give us that consistent thread across each of these things. So you can see here we have this concept of channels and a channel in Async API, and that maps very neatly to the concept of rules in Event Bridge. And in terms of the type of event, we see message properties of the message in Async API mapping to a detailed type in Event Bridge and a subject in CloudEvents. And the payload itself in Async API, we kind of we would define the payload within the properties key under message. Event Bridge calls that detail, and CloudEvents calls that data. And time is more or less the same across Event Bridge and CloudEvents. But this was really key to us unlocking our understanding of how the definition of an event could be consistent and coherent across these three things. So if you're kind of just getting started with Async API and CloudEvents, and you have another technology in the middle, this is a really useful exercise to go through. So if we zoom out a little bit and kind of introduce this diagram, this is kind of the high level flow that we ended up with in terms of our cross-domain events. So on the left-hand side here, we have our event sources, and these are internal to our domain, to the payments domain. So events really could be coming from anywhere within our domain, and indeed they could also be coming from external sources such as our third-party payment providers. We route those events to our what we call our private event bus. So that's an event bus that's just available to services and consumers within our domain. We have a rule then on that event bus, and that would match all the events that we were interested in. So all those payment authorized events. We send that off to an AWS service called Step Functions, which is essentially a state machine based workflow engine. So you can imagine just a flow of different transformation steps on the data in that event. Obviously, if we remember back to the previous slide, the fields mapping, the structure of the event payload in Eventbridge is very different to the cloud events structure. So what we're doing in this workflow is mapping that Eventbridge event payload over to the cloud events payload, which we're going to push out to our consumers. And the second kind of step that we have in that step functions workflow is a kind of encryption step using JSON Web Tokens. And we'll get into the detail of that a little bit later. So once those events are transformed and encrypted, we send those on to the public event bus. Now, the public event bus is where we have rules set up targeting our downstream consumers. So that could be the baskets domain or any other domain that was interested in payments events. And again, that's all rule driven. So we saw that example of a rule with the baskets domain subscribed to payment authorized e-commerce events. We could also have another consumer perhaps who was interested and subscribed to point of sale POS payment events. So these are just some high level examples, and we can see on the far side those event targets either another AWS account, another Eventbridge event bus, or the HTTP API destination. Let's look at discovery next. So big part of allowing our consumers to discover our domain events is of course documentation. To discover and adopt those events and consume those events, documentation is obviously super important, and we wanted a way in which we could automatically generate documentation that was really clean, really simple, and had examples in there as well, because examples make such a difference when you're talking about API documentation. A lot of it can seem abstract until you see that concrete example. Luckily for us, we defined our event-driven API using an AsyncAPI. So an AsyncAPI provides a generator tool. You can generate tons of different things with that tool, but you can also generate HTML pages that end up looking like this. So we take our AsyncAPI spec and we generate an HTML website based on that spec. So all of this content that you see on the page here, that was all automatically generated just from our specification, and that can be updated in our delivery pipelines as the underlying spec changes, and we get nice examples of those different events as well. Another tool in our tool belt is Backstage, which was originally developed at Spotify as a way of distributing and accessing API documentation across the Spotify organization. They've open sourced that tool, and so anybody can kind of spin up their own Backstage instance. We've done that at Lego. And so once we've created our AsyncAPI specification, generated our documentation, we can upload that to the baseplate, and that's accessible to any other engineers within Lego, but not publicly accessible. So offers out of the box discoverability and security on that documentation. The other thing I wanted to touch on here was the concept of event hierarchy. Obviously, we know that naming things is very difficult in software engineering, and event types are no different. And there's many ways in which we can name events. There's been different formats for doing that. What I would say is choose one that works for you. But what we found was a very kind of powerful pattern was this kind of concept of topical hierarchy. So we kind of see some examples here where we've got the entity and then the event name itself and then some metadata. By kind of using this dot notation format, we see some really powerful filtering patterns applied internally within our domain, but also for our consumers. They can be as granular as they need to be when subscribing to events. So you could subscribe to all payment events, all events about a particular entity or domain. You could subscribe to all authorized events within that payments domain, or you could be very granular and say, I just want to subscribe to the e-commerce payment authorized events or the point of sale authorized payments events. A really powerful technique there, and it might be of use in your applications. Another key point on discoverability is the evolution of your event schema, of your event payload. Changes to your event obviously happen, especially at scale, as those events try to cater for more and more diverse consumers. So what the kind of strategy that we've settled on is to handle changes to events via additions wherever possible, so to only be additive to our events. When we need to introduce a new field, rather than replacing an old field, add it alongside wherever possible. And if you do need to make breaking changes, such as removing a field or renaming a field or changing the type of a value of a field, so if those breaking changes really are necessary, then the sort of best strategy, the optimum strategy there is to introduce a new event type. And again, you can kind of use any naming or versioning mechanism that makes sense for you. But yeah, make sure you're introducing new event types if there are breaking changes. And what you can do to help your consumers even further is produce the old event and the new event simultaneously for the time it takes the new event to be adopted fully and the old event to cease being consumed. And that really minimizes disruption. So it doesn't put any pressure on the consumer to upgrade their consumption of the new event. They can do that in their own time. And also it doesn't hold up development on the producer's side. They've made the new event available, and it's now up to the consumer to subscribe to that new event. And in terms of then circling back to the AsyncAPI version, the version of your event-driven API, that then can be incremented accordingly. So if you have introduced a new event, you would tend to move to the next major version. Updates to events, we can stay on the same major version and increment the minor version. And any fixes to events or to endpoints, we would see that as a patch version. So let's take a look at enrichment. Should be a really interesting topic. So we saw in our the flow diagram of our cross-domain events, we had that step functions workflow running to transform our event from the incoming format in Event Bridge to the outgoing CloudEvents format. And of course, as well as just kind of transforming, there's also usually enrichment. We want to derive values of fields from other fields. We want to change and operate on certain field values. And often to achieve this, we need to introduce a lot of kind of custom business logic. And there's a ton of ways to do this. There's a ton of ways to write this logic. And often, as that logic grows in complexity, the event payloads themselves expand. The risk of changing and updating that enrichment logic increases. And these are things that are really easy to get wrong. Field names are very susceptible to inadvertent change, as are field values. And any changes that are inadvertent can be catastrophic for consumers. If they're expecting a field named client ID with an uppercase I and lowercase d, and they get client ID with an uppercase d, these kind of innocuous differences can be pretty catastrophic to the consumer. So what we were looking for was a way to do that in a standards-based way, driven by schemas, a common language and a common method for performing enrichment on our events. And what we settled on was a standard called JSON Patch. So JSON Patch comes with a number of different operations. We've listed them here: add, remove, replace, copy, move. So pretty much everything you would need in terms of enrichment of and transformation of event payloads. And you can we see an example here of this apply patch method being used from a JSON patch library. We take the inbound event and we apply the transform patch to that inbound event. So if we take the order ID field, for example, this is how it would come to us in the top level, order ID. And we see here on the third line of the patch, we have the operation to move the order ID from that root field to the nested path at /data/order ID. So pretty simple operations there, but this has given us now a standard way to express those. So any engineers coming to update this, they can read it, understand it immediately. It's very trackable through source control and pull request reviews. It really reduces the risk of errors. Event IDs is another thing I want to touch upon here. So again, this is a key piece of information in your event. It identifies your event uniquely, and you can choose a wide array of different values to kind of generate an event ID. But what we settled on was a spec called ULID, universally unique lexicographically sortable identifiers. And there's a couple of really cool things about these. So they're base 32 encoded, so the string is fairly succinct, although highly unique, and really low or really high collision resistance. Sorry. And another really interesting property of ULID IDs is that they can be chronologically sorted. So event IDs generated with different timestamps can can then be sorted. And we find that's actually a really good, a really useful property for our consumers to have that additional capability for sorting incoming events. Idempotency is another topic you can't avoid talking about in terms of event-driven messaging, and particularly cross-domain events. So we in the payments domain as event producers in this example, we had a situation where we could not guarantee exactly once message delivery, and that was for a few different reasons. Third parties couldn't offer us the same guarantee, or services we were using within AWS couldn't offer that guarantee. So we had a situation where we could be sending the same event to our consumers more than once. So we had to give our consumers a way to know if they'd already seen an incoming event or not. So they would check the event. Have I already seen it? No. Okay, carry on processing it. Yep, I've already seen it. Okay, that's fine. I don't need to continue processing it. And we put an idempotency key in every single event that we send to our consumers, and the value of that key has to be deterministic. So it has to be the same for every single instance of that event, even if the event is sent multiple times. The event ID could be unique, but the idempotency key must be exactly the same. And this is what a consumer can verify whether they've already seen an event with. And we use an MD5 based content hash for that. So we take the content of the event, which will always be the same, regardless of how many times we send the event, and we create a hash of that event content. And that's an example of how it comes out. Okay, so on to security. This is a short section, but obviously a very important section of the talk. So I touched on this briefly earlier in the talk, but our strategy for securing our events centered around JSON Web Tokens and a kind of a special way of producing JSON Web Tokens called nested JWTs. So with JWTs, you can sign those JWTs and you can encrypt them. But really what we wanted to do was both. So we wanted to nest an encrypted JWT within a signed JWT. So that's the concept of nested JSON Web Tokens. So in terms of signing our event, that allows our consumers to ask the question when they receive an event: is this event from a trusted source? Did this event come from the payments domain? Should I trust it? Is it safe and secure to process it? And so when we sign our event payload, we do that with a private key, and we share the corresponding public key with our consumers, and they can then verify that signature with our public key. And then we encrypt that signed JWT with a shared HMAC secret. We share that secret with our consumers, and that allows them to decrypt the event once they've received it. And another bonus you see here in the bottom right is that that's an example of a JWT. So it's consistent. It's always going to be the same size. It's highly compressed compared to the raw event, and that's kind of an added bonus of using JWTs. Obviously, we're using them for security, but that encoding and that compression is really useful when you're transmitting data of a variable size to consumers over the network. Testing, another super important topic really in terms of cross-domain events. We kind of used a varied testing strategy. Linting was a big part of that, so we can use this tool called Spectral to lint our async API specifications to make sure it kind of adheres to various rules and formats. We can also validate event payloads. So we were looking at the enrichment earlier, and we can also define our events as JSON schema documents. And when we enrich our events and when we produce our event payloads, we can then validate that enrichment process against a JSON schema definition of our events to make sure that the transformation and the resulting event payload adheres to the rules in that schema. And we do that in our unit tests pre-deployment of our solution, but we can also do that at runtime as well. Now it's really key in terms of testing event-driven systems to test your integration points. We kind of see two types of integration point in terms of testing. Integration points that we can test at build time via our infrastructure as code tests, and at runtime where we actually test deployed resources. Contract testing is another really powerful approach to when it comes to testing event-driven systems and cross-domain events. So what we can do here is put an event contract between our producers, between our producer and our event consumers. And essentially a contract in this case would be the JSON schema document definition of our event. We place that in a central registry where producers can distribute the contract and consumers can access that contract, and then we run tests against those contracts from our systems under test. So we can simulate event production or event consumption, and then based on the production or consumption of that event, we can verify that and validate that against our contracts. Observability. Now, observability really works in tandem with testing. So the areas we don't test or are very difficult to test in event-driven system, we make sure we optimize in terms of monitoring and alerting. And as we're running on AWS, we can leverage a lot of default service metrics to monitor the health of the resources in that event pipeline. We configure alarms on those key metrics, things like undeliverable events and the transformation workflow failures. We also use custom metrics a lot to kind of collect different data points about the application. And performance, of course, another critical thing for us to monitor. We want to make sure that our events are being delivered in a timely manner and are indeed being delivered at all to our downstream consumers. We do that through distributed tracing and dashboards as well. Okay, brilliant. So I think we're almost at time. So a quick recap of what we looked at today. We've looked at how we use AsyncAPI to define, document, and distribute our event-driven APIs. We've looked at CloudEvents for structuring event payloads in a common way. We've looked at Event Bridge. We've looked at JSON Patch for standards-based event enrichment. We've looked at JWTs for securing our event delivery. We've looked at test strategy and how we balance that with observability as well. And that's all I had time for. You can grab these slides by via this QR code. And if you like the talk, there's always more of this stuff from me on Twitter. So thanks so much for listening, and I hope you enjoy the rest of the conference. Goodbye.